Hello, ladies and gentlemen. This is Rui Guo, and my partner Zhendong is by my side. Today, we are presenting what we've done and what we've learned in Lab2. Okay, this is the bandwidth delay product we measure using the EE542. And in this table and in the graph presented, it is obvious that when we increase the delay, the throughput is actually decreasing. And from the graph, it is obvious that the higher the bandwidth is, when we increase the delay, the throughput decrease dramatically compared with the bandwidth when it is 100 megabits per second or 10 megabits per second. So I can say that high bandwidth is more delay sensitive. Okay, now it's my partner presenting.
Okay, for the fifth question in about 1.1. So when we change the window size from like 64 kilobytes to 256 kilobytes, we see that actually the throughput remains the same, which maybe we actually thinking about it, because since there's no delay, which means that each time you send the packages, and the other side will give you back a acknowledgement, and since there's no delay, so it will be done as soon as possible. So which means that the window size grows like normally. So which means like under these situations, the reason that why the throughput remains the same is that actually we haven't reached the max window size. And also we do some experiment, like we add some delays to the link, and at this time, if we change the window size from 60 to the bigger ones, and we see that the throughput actually changed when the window size is bigger, and the throughput will also be bigger. This is because if we add the delay to the link, which means that the window size will, the increase of window size will have some delays, which means that actually for the 64 kilobyte window size, which will like grow like slower than the bigger window size, which makes the throughput actually a little bit smaller than the bigger window size. So for the sixth question, so based on our throughput, it looks like that the window size doesn't affect the throughput under the zero delay, but when there's a delay on the link, I think the window size will affect it, and the bigger window size will have a better throughput under that circumstance. So when there's like 100 megabytes per second and 25 millisecond delay, the theoretically optimal send and receive window size should be like 1.28 megabytes. We calculated by we actually do the experiment on that. So we see that under these circumstances, we got 5 megabytes per second, which has a corresponding window size of 64 kilobytes. So we actually have to multiply it by 20 times, which actually we got the final result of 1.28 megabytes. So so actually we cannot achieve the 100 megabytes per second of throughput. This is because in real time there's always the delay and the packet loss, so we can never achieve the theoretical output. So for the part 1.2, we actually used tool to determine like the round trip time. So we got the round trip. As you can see in the picture, the round trip time is around like 25.662 milliseconds. So for the bandwidth delay product of UDP is 24.662 megabits per second, and the throughput of TCP is 808 megabits per second. So for the question 3, if we left the window at their default value, actually we got the good result. I think the default value is actually works in our situations. And for the fourth question, product. So we got the really small window size, which means that at this circumstance that the window size will limit the data which is pushed into the link. So at this time the window size will become the dominant factor of our throughput. But if we increase the window size to the optimal value, which means that it's match the bandwidth delay product, then at this time the bandwidth delay product will become the main dominant factor, which is the upper bound of our throughput. So as a result, that it doesn't make sense to that mismatch the window size and bandwidth delay product. That will limit our throughput. So for the question 5, it's actually to me a little bit similar to the question 3. I think when the window value is to something smaller, then you cannot push enough data into the link, which means that the link is not fully used. So at this time the window size will limit the throughput. So for the question 6, so we need to match the window size and the bandwidth product delay to achieve a good throughput. And also it asks us to measure the performance under the delay of 1 millisecond and 5 milliseconds. So under this circumstance that we see that the delay is reduced, which means the bandwidth delay product will also be reduced, which leads to the situation that the window size can also be shrink due to the reduction of the bandwidth delay product. So if you'd be happy with 1 GB DSL connection, I think I will not feel happy, because for the DSL connection, which means that we got the same speed for the 2 directions. So but for a personal user, we usually use more bandwidth on the download for downloading, but we actually don't upload a lot of things, so we need more bandwidth for our download. But under this circumstance that actually we got a lot of more bandwidth for the upload, but the download speed is actually a little bit lower than our expectations, so I will not feel happy with that. And here comes to the questions 7. So it asks us to add the packet loss to the link. So we add it and we test it, and we as it is shown in the picture that we dropped about 800 packets among all the packages, which is around 0.1%, which is actually within our expectations. So let's go to the part 2.
Okay, here is part 2, secure copy. Here we are supposed to send a file we created to another terminal to test the speeds. So for the question 1 and 2, as measure in the SCP tool, it actually show you the round trip time and bandwidth. So we only need to make the simple multiplication, then we can get a bandwidth delay product. And and question 3 and 4 and 5 is just some command line we input to finish our to complete the file transfer. And what does dd and if all this command line mean? First, double D is the name of a program used to copy and create a file. The IF is short for input file, so it means you can direct the input file, and OF means output file, so it means from the input file you can specify the destination of the output file. And BS stands for block size. Normally a file consists of several block size, so a block size here is 1 million bits, so 1 million bytes, and the count is we have 20 we have 20 blocks of this size. So in total we generate a file from the program urandom, which is used to create random data, I don't know, and output to a file called the data.bin file, and the size of this file is 200 megabytes. So, and after created this file, we can use the SCP program to send our file from one terminal to the other. The transfer throughput. In this case, we limit our bandwidth to 100 megabits per second, so the throughput is correspondent to the theoretical throughput, which is 11.2 megabytes. Here is the bytes, and the bandwidth is bits, so this one times 8 is actually close to 100 megabits per second. And increase the delay on this link, we can find out that to some point the throughput is actually decreasing, because like in the part 1 we already explained that higher the delay is, the higher the window size we should have. But here we didn't modify the window size, so the transmission speed is actually decreasing slightly. And because of SCP program is based on SSH protocol, and this protocol is built based on TCP connection, it should ensure all the data be transferred to the other side. So if there's packet loss happens or the delay, it will have the flow control or congestion control to lower the speed. And here we set the delay back to 0, and we are trying to simulate the transmission speeds when packet loss is injected. As we can see, the higher the packet loss is, the lower the speed, the transfer speed is, because SCP, as I said, SCP needs to make sure all the data is safely and securely transferred to the other terminal. So if a packet loss happens, it should retransmit the lost packet. So the transfer speed is slow if the packet loss is huge. And this is the question 11. Estimate the delay and loss from Los Angeles to Switzerland. Here, actually, we don't know specifically how to estimate, so we just measure the distance between Los Angeles to Switzerland is around 10,000 kilometers, and divided by the sound speed, the light speed, we get 33 milliseconds. This is the theoretical delay between these two locations, but actually there's the queuing delay, the router processing delay, and the transmission delay in between, so the actual delay should be greater than this number, but this 33 milliseconds is just a theoretical delay. Okay, we are finished in Lab 2. Thank you.